Think about all the things you ate or drank today. At breakfast, you probably drank some type of liquid, such as milk, water, or juice. And you probably ate some type of solid food, such as toast, eggs, or cereal. And all the time, without realizing it, you are breathing in different types of gases your body needs from the air. So, as you can see, the body needs liquids, solids, and gases to survive. What are some of the characteristics of these different forms of matter? What makes solids, liquids, and gases different from each other? And how can solids, liquids, and gases change form? During the next few minutes, we're going to explore these questions and many others as we explore some of the fascinating characteristics of solids, liquids, and gases. As you probably already know, all living things are made up of matter. Non-living things are also made up of matter. Even some things we can't see, such as air, are made up of matter. What exactly is matter? Matter is anything that has mass and takes up space. You decide. What is matter made of? All matter is made up of small particles. These particles are too tiny to see. The space between particles and the way they move determine whether matter exists as a solid, a liquid, or a gas. This scene illustrates three different states of the same substance. What is the substance? That's right, it's water. Water is an amazing substance found here on Earth in that it can exist as a solid, liquid, or gas. The different forms water can take are referred to as states or phases. For example, water can exist in the solid phase as ice, and it can exist in the liquid phase as liquid water. And water can also exist as a gas in the form of water vapor. Matter can actually be found in four phases: solid, liquid, gas, and a fourth phase we'll discuss later called plasma. This roller coaster, these icicles, and this cliff are all solids. A solid has a definite shape and volume. Volume is the amount of space that something takes up. Trees are relatively rigid, which gives them a well-defined shape. Why do solids have a definite shape and volume? The answer lies in the arrangement of their particles. The particles in solids are packed tightly together. This is one reason why solids are relatively hard and keep their definite shape. If you could closely examine the internal structure of many solids, you'd find they're made of crystals. A crystal is a regular repeating pattern of particles. Solids made up of crystals are called crystalline solids. Common table salt is a crystalline solid that has a square-shaped crystal pattern. This amethyst has a definite crystalline shape, as do snowflakes. While all snowflake crystals have 6 sides, no two snowflakes are exactly alike. Not all solids are crystalline solids. Some solids are called amorphous solids. Tar used to repair roads and candle wax are examples of amorphous solids. Windows are also considered to be amorphous solids. A window, while it appears to be quite solid, over many years may move and reshape itself, as seen in the glass of this old house. Let's take a look now at liquids. Every time you have a drink of water, wash your hands, or go swimming, you're coming in contact with liquids. Liquids are everywhere. In fact, over 60% of your body is made of liquid water. You compare. How are particles in liquids packed differently than those in solids? The particles in liquids are not packed as tightly together as in solids. They move more freely and thus don't have a definite shape like solids do. Liquids, therefore, take the form of whatever is holding them, such as this vase or this swimming pool. Even though liquids do not have a definite shape, they do have a definite volume. For example, this beaker contains 1 liter of water. And when the water is poured into this bowl or into this square container, it still has a volume of 1 liter. Perhaps you've noticed that some liquids flow quite readily and others flow slowly. Things such as honey and maple syrup flow slowly. Viscosity refers to the resistance of a liquid to flow. Fluids like motor oil have a high viscosity, meaning they resist flowing, whereas water has a relatively low viscosity, meaning it flows easily. When you first think of gases, you may think about gases coming out of a chimney or from the exhaust of a car. Or you may think of helium gas used to fill balloons. But did you realize that gas is all around us at this very moment? In fact, we're breathing in several different kinds of gases, including nitrogen and oxygen. Without gases, humans and most other living things could not survive. A gas has no definite shape and no definite volume. For example, this helium gas fills the shape of this balloon. Not only does gas have no definite shape, but its volume can vary. This is because particles in gases can freely move about and are packed very loosely. The volume of a given amount of gas can change and adjust to fill the volume of a small container or a large container. This balloon contains gas that has a specific volume. If we squeeze the balloon, it gets smaller, and the volume of the gas inside it decreases. So, as you can see, the volume of a given amount of gas can increase or decrease. If you've ever been outside in a strong wind, you probably felt the pressure exerted by gases against your body. Pressure is the amount of force exerted per unit of area. All of the air in the atmosphere exerts a downward pressure on us. So, as you can see, pressure is something we live with every day. Let us get back to our example of the balloon. This balloon contains gas. You predict. What do you feel when you push on the balloon? The balloon pushes back. This is because the overall pressure in the balloon increased when it was squeezed. We've already discussed 3 of the 4 phases of matter: solids, liquids, and gases. In a minute, we'll discuss plasma, the fourth phase of matter. But first, let's discuss how solids, liquids, and gases can change phases. A phase change involves the change of matter from one state or phase to another. Let's take a look at water, since it's commonly found in all three phases here on Earth. This lake is a great place for swimming in the summer, but as the weather cools, so does the water. In midwinter, the water gets so cold that it freezes. Freezing is the process of a liquid changing to a solid. You decide. At what temperature does water freeze? Fresh water freezes at 0 degrees Celsius or at 32 degrees Fahrenheit. The point at which a substance freezes is called the freezing point. In spring, as temperatures begin to warm, ice melts when the temperature rises above 0 degrees Celsius or 32 degrees Fahrenheit. This ice cream cone is also melting. Melting is a phase change in which a solid turns to a liquid. If you live in a northern climate, you're probably quite familiar with the process of freezing and melting. Have you ever thought about the process of a liquid changing into a gas? Vaporization is the process of a substance changing from a liquid to a gas. Vaporization occurs when a liquid is boiled. In the process of boiling, particles in a liquid actually change to a gas. You've probably seen water boil. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit, at which point liquid water changes to water vapor. You're probably familiar with the process of evaporation, which occurs when liquids vaporize at the surface. Evaporation occurs when mud puddles dry up, when a glass of water is left on a table for several days, and it occurs at the surface of sweaty skin. The last phase change we'll discuss involves the changing of a gas into a liquid. This process is called condensation. If you've ever noticed how a cold soda can develops beads of liquid on the sides, you've witnessed condensation in action. In the process of condensation, water vapor particles in the air are cooled when they touch the cold side of the can, and they experience a phase change from a gas to a liquid. Condensation is the process that forms clouds. Clouds form as water vapor changes to tiny particles of liquid water. Plasma is the fourth phase of matter. Plasma is rare on Earth, but it's one of the most common forms of matter found in the universe. Our sun contains a great deal of plasma. Plasma contains a great deal of energy and can be quite dangerous to living things. Plasma is a gas-like mixture consisting of charged particles. Plasma generally exists at high temperatures and can be observed in your home in fluorescent light bulbs. During the past few minutes, we've explored some of the fascinating characteristics of solids, liquids, and gases. We discussed how all matter is made of particles. The manner in which particles are packed together and the way they move determine whether matter exists as a solid, liquid, or gas. We discussed how solids have a definite shape and definite volume, whereas liquids have no definite shape, but they do have a definite volume. Gases, in turn, have no definite shape and no definite volume. We also discussed how gases react to variations in pressure and temperature. We explored some of the different examples of phase changes, including freezing, melting, vaporization, and condensation. Finally, we briefly discussed the fourth phase of matter, plasma. So, the next time you boil some water, see an ice cube melting, or take a breath of air, think about some of the things we just discussed. You might just think about matter a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Matter is made up of small. Number 2. There are phases of matter. Number 3. Is the amount of space something takes up. Number 4. A is a regular repeating pattern of particles. Number 5. Have a definite volume and no definite shape. Number 6. Refers to the resistance of a liquid to flow. Number 7. The air above us creates a downward. Number 8. Involves the change of a liquid to a solid. Number 9. Water boils at degrees Celsius. And number 10. Water freezes at degrees Celsius.